Next up, we've got Neil and Kai, and we've also got Terry and some other people who are moderating panels today. So thank you very much for joining. I'm just going to introduce this briefly. Ben, Evo, Neil, and Terry, who are all moderating panels today, started Metatraversal, which is the community event formerly known as Meta Davos 1 year ago. Julie, Karen, Sophia, and myself were in on it from the beginning, and we did 3 90-minute Zoom calls and a 2-hour streaming show with some of the leaders of the industry to demonstrate support for cooperation on interoperability. Then at AWE in June, we were all part of the Metatraversal, A Day in the Life, which was a 45-minute play. It was a fantastic production. And then Neil, in his capacity as president of the Khronos group, started Metaverse Standards Forum. And I think almost everybody on this call and watching by now will have heard of the Metaverse Standards Forum, which is becoming the de facto United Nations of the metaverse, and just in time as well. So we congratulate and thank you, Neil, for bringing together close to 2,000 entities, large and small, to cooperate on standards. Welcome, Neil. Welcome, Kai.
Great to see you, Daniel. Thanks for having us here.
Thank you.
So this is going to be a cool session. We were going to have Aitigal, who's the co-chair of the Immersive Web Working Group at the W3C, but she's feeling very poorly this morning, so get better soon, Aitigal. We wish you were here, but take care. But we have Kai, who is Kai Ninomiya, who is the specification editor on WebGPU at W3C and is a software engineer at Google Chrome. So we have folks here. The two of us, we can cover Khronos, Meta Standards Forum, W3C, and WebGPU. So the topic for this next 30 minutes is to give some of the context around the standardization efforts that are enabling XR in the web. As we all know, the web is built on open standards, and in particular, delivering XR on the web, it brings together multiple standards, multiple companies, and standards from multiple standards organizations. So it's a great example of wide industry cooperation. So we're going to explore in the next few minutes how these standards from both the World Wide Web Consortium, the W3C, and the Khronos Group are working together and enabling 3D and XR in the web, how they interact, some up-to-the-minute updates, and what's coming up. So let's start out. Kai, do you want to level set us? What are some of the high-level goals, and what's the high-order bit State of the Union on WebGPU right now?
Sure. Yeah. So everyone may have probably heard of WebGPU already, but WebGPU is an upcoming successor to WebGL. So, of course, WebGL is the wildly successful technology that drives all 3D on the web today. WebGPU will provide new features and new performance through things like compute shaders, which is really big, render passes, render bundles, and a bunch of other features that will provide more powerful and faster graphics and accelerated compute. So for things like machine learning or accelerated physics or anything else you can imagine, getting access to the GPU for that parallel compute can be really important. It also has a new shading language, WGSL, which we pronounce Wigzel. Wigzel is being defined in our group with very tightly defined semantics and static analysis so that we can ensure the best portability for applications. So you can write your application once and run it anywhere with fairly minimal testing compared with a lot of native development, especially where you really have to test on a lot of different GPUs and operating systems and different versions of drivers and things like that. And so we're trying to smooth things over as much as we can at the API and the language level. So standardization-wise, standardization for WebGPU is ongoing. The spec itself is in very, very good shape. So we have we're very close to 1.0 in terms of the API and the language. We can't promise any timeline because standardization is a complex multi-company process, as I'm sure you can appreciate. But we've been working on it for more than 5 years now. We started standardization in 2017. And so really at this point, the API has had a lot of attention and it's very polished. And it's really just about finishing that long tail of defining semantics, writing tests, getting implementations complete before we can release. And so we estimate, no promises, we can't promise anything because standardization is so complex. But our estimate is that around the end of this year, we'll have WebGPU, the standard and implementation, and at least Chrome's implementation ready, followed by implementations in other browsers, hopefully soon after that. But I, of course, can't give timelines for browsers.
Sure. Yeah. No, it's pretty impressive actually, because you're right. Standardization takes patience.
Yes, it's a lot of work, but it's very rewarding. In the end, we get something that's really, really useful and really well made for users, and something that we can build upon so that we can provide the features that people need in the future.
Yeah,
we have a lot of work to build out the API now that once we have the foundations.
Yeah, no, it's interesting because some people that haven't been involved in standardization, they'll say, "Oh, standards are so slow, and it must be very frustrating." And sometimes it is, but overall, if you do have the patience, being able to leverage standards to build a worldwide pervasive platform like the 3D in the web today and its evolution into WebGPU is a pretty amazing thing to do, and it is. Yes. It's a roller coaster, but it's worth it. So
absolutely,
yeah. So we'll dive into more details on WebGPU. Just kind of get all the coins on the table. I know you're not directly involved with W3C, and we don't have Asiable here, but from what you know, can you give from the W3C perspective what you do know about the current status of WebXR?
Yeah, so I'm definitely not involved in it myself, but I can provide Ashigul's update. So unfortunately, she wasn't able to make it, but she was able to provide an update. So she says the immersive web working group is the group at the W3C that works on WebXR APIs. The WebXR APIs are candidate recommendation, which is one of the near final steps in the recommendation process of the W3C, which is sort of the ratification, where it becomes an official recommendation of the standards body. The AR module and gamepad APIs are in review to reach candidate recommendation, so they're expected to be there reasonably soon. It's it's a standardization process. It's a little bit slow, but this is really just like the formalization of the API. So those are stable at this point and ready to be used. The charter for the Immersive Web Working Group has also been extended for 2 years. Their plan of work is agreed upon by the participating companies in that working group, so you can expect lots more good work to come out of that group in the next couple of years, and of course beyond that.
Yeah, no, it's pretty cool that there is so much activity, and of course we're here as a good example of that. So much activity around WebXR as the final specifications come into place. So when we get the final specifications, we know it's going to meet the needs of the industry. Did Meta Connect was earlier this week? Did you see the announcement they had around WebXR, that they're actually supporting pass-through AR?
Yeah, I saw a tiny bit of it. I haven't been following super closely because I've been very busy with other things, but yeah. I heard tidbits.
Yeah, it's pretty cool. The demos look awesome, and I think it's a great exemplar of how AR is going to be available in WebXR, which is very cool. Okay, so let me return the favor. Let me give just kind of a high-level context on the Khronos side and the Metaverse Forum, and we can dive into more detail. So, Khronos and W3C have a long relationship, and we love working together with the W3C. And I think WebGL was a Khronos standard, but WebGPU is at W3C. But I think that's a pretty logical way to organize things. Khronos focuses on the native APIs, Vulkan for accessing GPUs and OpenXR for accessing the XR hardware. And then the W3C does the good work and a pretty heavy lift to lift those native capabilities up into the web stack. So the state of the union of Vulkan and OpenXR is pretty good. They're both unique in being the only native APIs that provide cross-platform, cross-vendor access to GPUs and XR hardware, and both are being widely adopted. OpenXR in particular is being picked up by pretty well every XR headset manufacturer, including Meta and Qualcomm and others. So that's good. That gives the wide availability into XR hardware that that the web APIs need, because of course the web has to run everywhere. And so if you can help at the native level to let the web stack run easily across multiple hardware, that's good for everyone. We also find that we kind of stumbled into it, but 10 years ago, but we found that APIs often need data formats to feed them. What they're going to be processing, and in the 3D space, Khronos has for over a decade now launched and has been evolving the glTF 3D asset format, and we can go into more details. But it's essentially the equivalent of a JPEG, but for 3D. It's easy to process and widely available, and we're busy evolving glTF right now from a 3D asset format, which is just meshes and textures and the visual appearance, into what we're calling a metaverse asset format, adding behaviors in the format that a metaverse environment can use if it chooses to. Physics attributes, so glTF assets can participate in the physical simulation, and anchors. So if you're bringing a glTF asset into an AR environment, you can use anchoring as defined in the asset too. And the last thing, Daniel mentioned the Metaverse Standards Forum. Of course, the W3C and Khronos working together is just one example, but if you zoom out to the larger metaverse, there's so many more standards that we're going to need to bring all of the novel technologies that are going to make up the metaverse, bring them together and make them work together. No one or two standards organizations can possibly create all of the standards we need. We're going to need a constellation of standards, trademark. And that's why we created the forum, simply so the standards community have a place to communicate and to reach out and interact with the wider industry. And as Daniel says, as of yesterday, we have actually just broken the 1,900 member barrier. So it shows there's a lot of interest. I take it as a lot of interest being expressed for the metaverse. A lot of folks have been working on metaverse standards for many years. I mean, Khronos has been working on 3D APIs for over 20 years. Suddenly it becomes a metaverse standard, which is great. It has really put a lot of more emphasis and interest in the whole sphere of standardization and interoperability, which I think everyone in the standards community really welcomes, and we hope we can respond. So on the WebGPU, let's dive into a little bit more detail. Do you want to kind of explain a little more how it fits into the stack? What APIs are you building? It's not just Vulkan, right? There's other APIs too. And what engines are you finding are using WebGPU?
Yeah, of course. So WebGPU primarily is built on top of three native APIs, Vulkan, Metal, and Direct3D 12, so that we get access to all platforms. Of course, there's the possibility of implementing WebGPU on top of other APIs. So, for example, console-specific APIs, OpenGL for compatibility with older devices. But the three that are targeted for the design of WebGPU and for the first implementations are Vulkan, Metal, and Direct3D 12. So WebGPU really provides a common core of functionality that you can find on every device out there that supports one of those three APIs. And as a result, it is also a hardware abstraction layer for all those, right? Like, it's not just a web API, right? We put a lot of design effort into creating something that would be consistent and portable across desktop and mobile devices, across all operating systems, across all of these backends. And so as a result, it is a really stable hardware abstraction layer for applications on the web or in WebAssembly or in native. So we have native headers that are in development that provide the WebGPU API in C as well, or C++. And we really think that WebGPU has potential to become this sort of provide the consistency, the portability that you expect from the web across all platforms. It will never be able to provide the power of the native APIs because we are building that common core, right? So there's very much a place for the native APIs underneath, and very much a place for applications that use those. But when you're looking to target, especially if you're looking to target the web, but if you're looking to target a lot of devices with less effort, we hope that it will be a really good abstraction layer for developers. So as far as engines and projects that are using WebGPU right now, so we haven't released the 1.0 spec, so everything is provisional, but there is provisional support in Babylon.js. They announced their full support for WebGPU and Babylon.js a couple of months ago. I forget when, earlier this year. There's also a very active development going on in 3.js, so I think you can try that out today. Unity, PlayCanvas, BGFX. There's an Unreal Engine rendering plugin under development somewhere. There's a lot of work going on to get to bring the power of WebGPU to more applications that target web. And as I mentioned, it's also hardware abstraction layer. So there are some projects that target, that are written in C++ or Rust, Rust especially, that target both the web and native, and can cross compile to like web, Windows, Android, etc., with just one rendering backend.
Yeah, that's cool. Rust is cool. It's good to see Rust being picked up by the industry, and it's cool as well that there are so many of the key engines are exercising WebGPU, as you say, as you come into final approach on the final specs, just like WebXR. Yes. It's good to have that real world software using you to polish off those final. I
should probably give a little bit of context with WebXR. So I haven't mentioned, since I don't work on WebXR myself. WebGPU is not quite done yet, not quite shipped yet. We have not gotten to the point of integrating WebGPU into WebXR yet. So right now, for 3D and WebXR, you still need to use WebGL. That's something we expect to be doing very soon after we finish the V1 release. We've just been very focused on getting WebGPU out the door. The integration with WebXR will not be super complicated. It'll be very, very similar to WebGL. So we are expecting that to go pretty quickly once we reach that point. But we've been sort of heads down in the standards work for WebGPU. Soon, yeah.
But a shout out to WebGL too. I mean, WebGPU is going to be awesome, but WebGL is providing all the 3D in the web today. So we don't want to scare people away, saying we don't want to. People don't have to wait to use WebXR for WebGPU. It's going to be a great upgrade, but WebGL is providing a great platform today.
Absolutely. We continue to support. We will continue to support WebGL for a long time. It will continue to be very stable for a long time, and it also provides wider support since it has a lower hardware requirement.
Right. Yeah, that's cool. And the engines using WebGL now and WebGPU coming. it's very interesting because all these companies kind of orbiting around each other, and the standards organizations. I mean, one of the big topics that's coming up from the tooling companies and the engine companies is around 3D asset formats. Now, glTF is not the only asset format out there. You know, the other one that's getting a lot of deserved attention is USD, Universal Scene Description. But it's interesting. It's from a different organization. In fact, at the moment, it's not even an open standard. It's an awesome open source project that's been released by Pixar. USD is essentially a set of schemas and a whole bunch of open source software that Pixar have been using to make their movies. And now companies like Apple and NVIDIA and Autodesk and Adobe are figuring out how USD can be brought into other market areas. So there's a lot of, every day, Khronos gets asked the question, so how does glTF and USD going to interrelate, and how should I use one or the other? And it's a very interesting question that we're going to have to figure out as an industry over the next few years. Right now, I think it's pretty accurate to say that USD is primarily used on the authoring side because it comes from the Pixar movie making heritage. And glTF from the get-go, from 10 years ago, had this very specific goal of being a delivery format that could be processed easily everywhere. So right now, people are, if they're using USD, they're typically using USD in an authoring format, and then USD assets can get distilled down into glTF. You wouldn't send a USD file typically to my mom's cell phone, but you would send a glTF file. Now, Apple has the USDZ format, which is a zipped version of USD, which is closer to glTF. And I think Apple are going to be using that for their platform. So there's lots of translators in and out of glTF and USDZ, just like we layer Vulkan over Metal. So there are ways of bringing these different ecosystems together for developers. But the evolution, the roadmap question around glTF and USD is an interesting question. It needs input from the wider industry and multiple organizations, including Khronos and Pixar and many others. And then that's an example of the value that we hope the Metaverse Standards Forum can provide. We have these 1,900 members. The first thing we did was poll them, asking them what were the key pain points or opportunities for standardization. And number one was glTF USD interoperability. What are we going to do? So we now have a domain working group being established where we're actually going to try distillation and interoperability using the two formats in different use cases, different pilot projects, developing tooling. So hopefully we can create a fact-based coherent roadmap together and make things coherent for the industry. So I think that would be good for everyone.
Yeah, standardization is very powerful, as we've been saying.
Yeah, and the more people you can bring into the discussion and build a wider consensus, the larger the end benefit can be if more people pick it up and use it. So we're looking forward to that. So let's go back. You mentioned the roadmap for WebGPU. I don't think most people realize just what an awesome job the browser vendors do to WebGL today, WebGPU in the near future. How much effort and investment and care it takes to make the web the most reliable, portable 3D platform in the history of the known universe. I mean, do you want to talk about that? I mean, the angle and all the driver bugs you have to work around. I mean, can you give the folks here some insight as to just how much engineering work goes into that?
Sure. Yeah. Yeah, it is. I mean, web browsers are an incredible effort. I mean, they take hundreds of people just to maintain, I would say. And our team has been working on WebGL. So I joined this team just before the release of WebGL 2. So we were hammering out some of the final driver bugs and things like that just before release. But people use WebGL a lot, and we hear about a lot of issues that people run into on different devices. We'll find driver bugs on every platform. Every platform has many graphics driver bugs and graphics issues. Desktop platforms, mobile platforms, everything. And so it's really been it's a big project. It's been a big project for many years. Right now we have basically 2 people working on WebGL still on our team, because there's consistently work to do, right? We have to be working alongside folks who are working on refactors in the browser engines, who are trying to improve performance and power consumption, and take advantage of new platform APIs and OS APIs, and at the same time, trying to maintain our code, make sure that when a new driver bug pops up, we're able to handle that, and we're able to prevent that from reaching users as best we can, so that users have a really consistent experience, and so developers don't have to deal with inconsistent issues across devices. And of course, there's big work as well there's big work as well on bringing WebGL on top of Metal, which is a project that we've been working on for a couple of years now.
Yes.
On Mac OS since Apple's deprecated OpenGL. A big project has been bringing things on top of Metal and getting the performance and the more reliable, more maintained drivers that come along with that. So yeah, there's just tons of work. And so that's just Chrome, but of course all the browsers have similar experiences. Angle is a project that's shared, especially on Windows, a project that's shared across multiple browsers to implement WebGL and OpenGL ES on top of Vulkan, Direct3D, multiple different APIs, and again with that consistency, that highly standardized layer that handles a lot of driver bugs and things like that. So there's a lot of components that fit together, and a lot of folks working on. I said there are 2 people working on WebGL. There's a bunch more people working on Angle, right? So it's really a huge effort to make all this stuff work.
It's hundreds and hundreds of man years, and I think it's not just the accessibility of the web and the portability of the web; it is the reliability of the web. People should really, I think, shout out to the browser vendors for making that happen. And with WebXR, of course, it's going to happen for the XR, not just the 3D. So yeah, the web for the win. Hey,
thank you, Neil and Kai, for the fantastic conversation. Good to know we're in such safe hands. And when we're talking about production, it sounds like you guys are making production possible. But having said all of that, rather you than me. I'm not a coder. I'm not a developer like that. So hats off to all of your efforts. And thank you so much. And keep up the great work. Obviously, this whole industry is watching for WebGPU coming out. Can't come soon enough, I'm sure, for some people. Thank you, Neil. And thank you, Kai.
Yeah, that reminds me, I should squeeze one really quick thing in.
Go on, Kai.
Yeah, so I forgot to mention this, but you can use WebGPU today in Chrome. It is shipped as an origin trial. So this means that you can get provisional access. You can use WebGPU on end user shipping websites on devices that support it. So take a look at the origin trial if you want to try out WebGPU now.
Thank you so much, Kai. Thanks for getting that in before you leave.